The first two laws of thermodynamics were both discovered in 1850. The person who got in first and published it was Rudolph Clausius. And for the second law of thermodynamics, he just pointed out that heat flows spontaneously from a hotter to a colder body, but not in the opposite direction. And that was the first precise observation that underlay the development of the second law of thermodynamics. And then very quickly, it was Helmholtz in Germany who coined the expression heat death. So heat death was a concept by 1855. Meanwhile, Clausius was working away on his precise concept of entropy, and in 1865 was when Clausius made those two notorious statements that I mentioned. A person we should mention, and I didn't mention nearly enough in the Jana's point or in what I put on my website, is the work of Gibbs in the United States, who did marvelous work. Einstein, in a way, rated him even higher than Boltzmann. And Willard Gibbs is his name. And he just did fantastic work. And I think you can say he's the founder of sort of physical chemistry. He developed things in such a way that a huge amount of scientific applications, engineering applications, go back to the work of Gibbs. And all of that relies on the equilibrium state. And in fact, a huge number of scientific discoveries were made in thermodynamics and statistical mechanics from the properties of systems when they are in equilibrium. So that led to the first reliable predictions of the number of molecules in a gram, what the size of the molecules are, what the, things like that. And then finally, it led on in 1900 to the most amazing discovery, the first discovery of quantum mechanics by Planck in 1900. So all of this putting systems in a box was extraordinarily effective. In fact, I recently, a few months ago, I published a paper called Gravity's Creative Core, in which I mentioned the British, the English philosopher and politician who, what's his name now, in Queen Elizabeth's time. I'm getting terrible in remembering names, but he said that he's reputed to have said that you had to torture nature to get her secrets. And who was anyway? It may come to me before I finish. My brain continues to work very well for the physics, but for the names, I'm afraid it's not so good. Let me just continue that story. So
I'm just looking it up.
He said that. Okay, you'll come in a minute.
Bacon?
It's Bacon.
Yeah.
Francis Bacon. Francis Bacon is the man here, and. He apparently, really, what he was saying, that we had to struggle with nature to get its secrets. But I very much like the idea of torturing nature, because in fact, what physicists did in the 19th century by putting physical systems in a box and studying them in equilibrium was in a sense, you can say, putting them in the box was putting them in prison, and then increasing the pressure or the temperature or so forth. Those are like the screws when you torture someone. And this indeed, out of this torture, nature did give up most amazing secrets. However, the final thing, nature got her own back by saying yes, and the reward for all that is heat death. But in fact, I think I can finish in that thing. I do recommend anybody who's interested to read that. it's on the archive. It's Gravity's Creative Core, and I say, well, maybe you have to let nature free, let it explore the whole of all the possibilities, and then you see that actually structure comes. It's just completely different, I believe, between a system which is essentially confined and in a box, metaphorically speaking, and one that can explore all possibilities. And so I quite like that conceit, as one calls it, of nature getting her own back for being tortured and giving up all those secrets, marvelous as they are.
And just for our listeners who aren't familiar with this term, heat death, it is, as far as I'm aware, and maybe you can put a more precise gloss on it, but going back to this era of equilibration, the idea is that as time goes on, the highly ordered state dissipates into something approaching equilibrium, so that as time goes on in the universe, these ordered structures like stars or people will slowly disintegrate to this uniform state where atoms are just moving about randomly and hardly ever touching each other as the universe expands.
I guess that's more or less how people think about it. Personally, I think there's a lot of issues related to black holes and things, which I would say is still a bit open.
I thought that with
certainly for
sorry, I was going to say that I thought that
systems in a
Hawking radiation, the black holes would also dissipate because they will slowly lose mass.
That's what Hawking's theory, and it does seem to be fairly secure. But there's mysteries about Hawking's work, and I would say I'm not really. I wouldn't pretend to have too much expertise in that. I only read things about it. There is a thing, because the universe is now observed to be its expansion accelerating, that leads to another effect, which is a bit like putting the whole universe in a box. It's when you things disappear because they're moving away so fast. And that is why, for example, Sean Carroll argues that the end state of the universe will be entropic. Now, that may be the case. I think I may be wrong. Maybe that is right. But certainly, I would say it's still uncertain. There's so many puzzles in cosmology. I mean, cosmologists they have great difficulty really in explaining how structure comes. There is a theory of inflation, but I think people are getting progressively more uncertain about it. And now there are major differences, a thing called the Hubble tension, where there are two different ways at which you can deduce a very important quantity, the Hubble constant, and they differ by about, I think it's 6 or 7%. That's a significant thing. Then the biggest one of all is that physicists only can observe and understand only something like 6 or 7% of the matter in the universe. There's about a quarter of the matter is in dark matter, they think, and then the rest is in dark energy, and they haven't any idea what either of those are. So, I mean, at the moment, cosmology is in a way, there's a very fine theory, a concordance model, which gives very precise results, and you use only 6 or 7. There's a very nice book by Martin Rees, Just 6 Numbers, which go into a model to explain it. But where those 6 numbers come from, some of them are utterly impossible to understand, and others are a bit put in by hand. So I think it's just too early to say.